So last time we looked at how to solve simultaneous equations by finding what one variable equals and then substituting that back into the original equation. And that works pretty well most of the time, but there is another method which is often faster, and it's called combination or linear combination. So if we have an equation set up like this, 2x plus y equals 3, x plus y equals 6, what you'll notice is that in both of them we have a plus y. So since we have a plus y in both of them, we can just eliminate it from both. But what we're actually going to do here, in order to do that, is subtract the bottom equation from the top equation. And in order to do that, we can just look at each piece. They're set up in the same format. X's plus y's equals a number. So let's subtract. 2x minus x is x. Y minus y is 0, so there's nothing. We eliminate the y's, and 3 minus 6 equals negative 3. Now to solve for y, we already know exactly what x is equal to. So let's use this equation. X is negative 3 plus y equals 6. So y will be 9. So we have negative 3, 9. Okay, let's try something a little more challenging. 3x plus 2y equals 7. X plus 2y equals 1. So now here we don't have a single variable, but we do have 2y in both of them. So when we subtract, the 2y is going to be eliminated. So let's do 3x minus x is 2x. 2y minus 2y is nothing. 7 minus 1 is 6. So we subtracted the entire bottom equation from the entire top equation again. And from here we can see that x equals 3. Now we can put that back into either of these two original equations. So if we use the second one, we'll get 3 plus 2y equals 1. 2y equals negative 2, y equals negative 1. And the solution here will be 3, negative 1. So this method is actually pretty fast most of the time. But here we're going to add in another element. Now we don't have anything that's the same in these two equations. But look here, we have a 4y and a 2y. So what if we just multiply this entire second equation by 2? Then we'll have a 4y in both. So we'll end up with 2x plus 4y equals 6. We multiply everything by 2. So let's copy back down the first equation now, so they're right next to each other. And now we can easily see what to do. Subtract the bottom one from the top one, and we'll get negative 3x equals negative 2. So x is 2/3. We'll substitute that back in. We can pick any of these equations with both x and y. Let's pick this one. It looks the simplest. We'll have 2/3 plus 2y equals 3. 2y will be 3 minus 2/3 will be 2 1/3, or 7/3. So y will be 7/6. And the solution is 2/3, 7/6. Okay, let's do one more like that. Throw in some negative signs. We'll get negative 5x plus 2y equals negative 10. and 3x minus 6y equals negative 18. So now here, what looks like, which equation can we multiply to get something that's the same in both? Well, we have negative 6y here and 2y here. Now, then we're not going to get a negative if we multiply it by 3, but that's okay. Let's multiply this top equation by 3, so we'll have a 6 in both. We'll get negative 15x plus 6y equals negative 30. So now look at these two equations. Instead of subtracting, let's add them, because then we'll have 6y and negative 6y, which add to 0. So once again, the y's will be eliminated. So if we add these two, then we'll get 3x plus negative 15x is negative 12x. Negative 6y plus 6y is 0. Negative 18 plus negative 30 is negative 48. So x equals 4. Now for y, let's pick any equation. We'll get, let's use this one, we can say 3 times x of 4 minus 6y equals negative 18. And we will solve this. And the solution is 4, 5. Okay, let's try negative 15x minus 2y equals negative 31. Negative 4x minus 6y equals negative 11. So same thing here. I think you can see what to do. We'll multiply this first equation by 3 so that we have a 6y in both. So we get negative 45x minus 6y equals negative 93. Now, if we add these, we're not going to eliminate the y's, but let's go back to subtracting. Negative 6y minus negative 6y is negative 6y plus 6y. So the y's will eliminate if we if we subtract, because subtracting a negative is the same thing as adding it. Negative 6y plus 6y. So when we subtract, negative 4 minus negative 45 is 41x. Negative 6y minus negative 6y is 0. Negative 11 minus negative 3 is 82. So x equals 2. So let's plug that back into the first equation here. And we will get y is 1/2. So this is 2 1/2. Alright, let's add in one more thing. Now this problem is at the level where you will typically see these simultaneous equations. Okay. So what you'll notice about this one is that we can't multiply either equation to get one of the coefficients in front of one of the variables to be the same in both. So what we have to do is multiply both equations separately so that we are able to do that. So we can either try to get the coefficient of the x's to be the same or the y's. Let's just pick the x's this time. So how do we find what the common coefficient for x has to be? Well, that's going to be the lowest common multiple of the coefficients is going to be the easiest. So what's the lowest common multiple of 7 and 2? That's going to be 14. So in order to have 14x in the first equation, we need to multiply everything there by 2. And in order to get 14x in the second equation, we need to multiply everything there by 7. So now let's go ahead and do that. We will have in the first equation 14x minus 8y equals negative 6. And in the second one, 14x plus 35y equals negative 49. So now to eliminate the 14x, we'll subtract the second one from the first one, and we'll get 14x minus 14x is 0. Negative 8y minus 35y is negative 43y. Negative 6 minus negative 49 is negative 6 plus 49, which is 43. So y is negative 1. Now put that back into which one looks the easiest. This second one doesn't look too hard. 2x plus 5 times y of negative 1 equals negative 7. So 2x minus 5 equals negative 7. And x is negative 1. So the solution here will be negative 1, negative 1. Okay. Let's make things a little more challenging here with this next problem. Okay. Actually, well, if you see what to do here, if you look at the y's here, we're going to be doing a lot of high multiplying because the LCM of 7 and 9 is 63. But so let's use the x's again, then this isn't too hard. We have 2 and 3. Don't be thrown off by the negative sign. That's okay. We can just multiply by positive numbers. We want to have 6x in front of both equations. So let's multiply the first one by 3 and the second one by 2. So we'll get 6x plus 21y equals 12, and negative 6x minus 18y equals 6. So because we have a negative here, we're not going to subtract. We can add 6y plus negative 6x plus negative 6x. That's going to disappear. So now if we're adding, 21y plus negative 18y is 3y, 12 plus 6 is 18, and we get y equal to 6. Plug it back into the first equation. And we get x is equal to negative 19. So the solution is, careful with your x and your y, it's negative 19, 6. Alright, let's bring in some fractions. 3 over 2x minus 5 over 2y equals 3. And negative 15x plus 25y equals negative 30. So what do we do with fractions? Well, let's get rid of the fraction. Take the first one and just eliminate the fraction first. So multiply everything by 2. And we'll get 3x minus 5y equals 6. So now we have equations that we can work with. Pick either the x or the y. Let's just pick the y this time. So if we want to get the y's to be the same, all we have to do is multiply this equation here by 5, and then we'll have 25y in both. So we'll get 15x minus 25y equals 30. So let's bring down this equation here. Sometimes it helps to do that so that you can see them side by side. So now let's add them so that we can eliminate negative 25y and 25y. We'll get 15x plus negative 15x is 0. Negative 25y plus 25y is 0. And 30 plus negative 30 is 0. Now what in the world is this? We just simplified all of this down to 0 equals 0. How did that happen? Well, here's why. There are infinite solutions. And here is the reason for that. Because we were able to boil everything down to 0 equals 0, what we did was we eliminated all the variables. And because we were eliminate all the variables, that means the variables don't matter. Whatever numbers you put in for them are going to work, since ultimately they're going to get eliminated anyway. Because they're going to get eliminated, when we simplify it, whatever values they are, they can be any values, since they'll get eliminated. And because they can be any values, there are infinite solutions to this system of equations. Now let's look at one more interesting example. You can probably guess what's coming next. But here is what will happen here. Okay. Let's pick the x's this time. How can we get the x's to be the same? Let's multiply this top equation by 2. We'll get 2x minus 4y equals 6. So we're trying to get the x's to be the same, which means we're trying to eliminate the x's now. So let's subtract the bottom equation from the top equation. 2x minus 2x is 0. Negative 4y minus negative 4y is 0. So we have 0 over here. That's already a sign of trouble. 7 minus 6 is 1. Now, this is pretty simple. We eliminated all the variables, but what we ended up with is not 0 equals 0, which is a correct equation. We ended up with 0 equals 1, which is incorrect, meaning there was no solution here. Because when we simplified it, all the variables got eliminated, and we ended up with something that was incorrect. Meaning that whatever we put in for the variables, since they're going to get eliminated anyway, we'll always end up with an equation that is incorrect, and there is no solution. Alright, let's do one more. Let's jump out of the standard form of x plus y equals a number, and you're going to have to do a little more work here to get things in the form you want. So, in order to combine equations here using this method, you have to have both equations in the same form. The easiest form is the form we've been using, the standard form. X's plus y's equals a number. So let's do that to both equations. With the top equation, we have 3x, bring the negative 18x over. It'll be positive, so we'll have 21x. Now we have negative 5y minus 3y will be negative 8y. And 7 minus 6 will be, well actually no, sorry, we will be bringing the numbers to the right side. So we'll have 6 minus 7 equals negative 1. Now here we have 9x, negative 2y, we'll bring the negative 7y over, it'll be positive, so negative 2y plus 7y is 5y equals 8. So here we're going to have to multiply both equations. As you can see, we can't just multiply one of them to get the numbers to be the same. So be very careful in which one you choose here, because if you pick x, it's going to be very difficult because 9 and 21 have a very high lowest common multiple. So make sure to pick the y's. Then you only have to multiply this one by 5 to get to 40, and you have to multiply this one by 8 to get to 40. So we'll do the top one. It's already fairly high numbers. 105x minus 40y equals negative 5. And down here, 72x plus 40y equals 64. So, what can we eliminate? We can eliminate the y's by adding. So we'll add both equations together. 105x plus 72x is 177x. Negative 5 plus 64 is 59. And we'll get x equals 1/3. Now we can put that back into an equation here. Let's pick the second one. We'll get 72 times x of 1/3 plus 40y equals 64. So that's 24. 40y equals 40. Y is 1. So all this stuff up here, put it in standard form, combine the equations, and you get 1/3 1. Isn't that nice how it boils down to something, just a nice simple solution. Okay, and that is going to be it for now on linear systems, but eventually, maybe in the next video, maybe in a couple videos, we will do something a lot more difficult. We're going to add in 3 variables, but that will come soon.